the PI of the Indigenous Food, Energy, Water Security, and Sovereignty Program, which is funded by the National Science Foundation. Dr. Kim Ogden, Dr. Radcliffe, Dr. Caranicola, and Dr. Bob Arnold, which are all in chemical and environmental engineering, are PIs on this grant. So we're really excited and thankful for the co-sponsorship of the Chemical and Environmental Engineering Department this semester. The IndigiFuse has been having this Native Voices in STEM seminar series for several years now. And more recently, we have been working to co-sponsor it with a variety of departments, starting with the School of Natural Resources and the Environment, last semester with environmental science, and this semester with chemical and environmental engineering. Next semester we'll have it with hydrology and water resources. And then thereafter, the seminar series will be institutionalized through the Office for Society and Sustainable Impacts. So I'm very excited to kick the semester off, and just want to thank you for joining us today. We have several of our IndigiFuse trainees that are part of CHI, and traditionally we like to have them introduce the speaker. So at this time, I'm excited to transfer the mic over to Anton, who is a PhD student in CHI. Thank you.
Hello, everyone. My name is Anton Samoilov, and thank you, Dr. Chi, for handing it over. I would like to begin introducing the seminar series by first stating the University of Arizona land acknowledgement. Obviously, we would like to respectfully acknowledge the University of Arizona is on the land and territories of Indigenous peoples. Today, Arizona is home to 22 federally recognized tribes, with Tucson being home to the Tohono O'odham and the Yaqui. And committed to diversity and inclusion, the university strives to build sustainable relationships with sovereign Native nations and Indigenous communities through education offerings, partnerships, and community service. And so, as Dr. Chief previously mentioned, the Native Voices in STEM seminar series is co-sponsored by the NSF&RT IndigiFuse program, the University of Arizona-Sloan Indigenous Graduate Partnership, the Water Resources Research Center headed under Sharon Megal, and the Department of Chemical and Environmental Engineering. So we are very excited to share this partnership this semester for this seminar series. And so for our speaker today, we have Dr. Ranalda Tsosie, and she is a postdoctoral scholar at Montana State University in Bozeman, Montana. She is currently working on a point of use filter optimization project and continuing to work with Indigenous communities and water challenges. So Dr. Tsosie completed Ph.D. in Interdisciplinary Studies. So these studies encompassed a variety of subjects with emphasis in chemistry, geosciences, and environmental science studies from the University of Montana. So her graduate research project actually brought together Diné and Western scientific perspectives to address water contamination in her home community of the anglicized name being Sweetwater, Arizona, in the Four Corners region of Arizona and the surrounding communities. She has a lot of experience working in Indigenous communities themselves, implementing and practicing Indigenous research methodologies. And in her free time, she enjoys a variety of hobbies, including beading, sewing, practicing traditional Diné arts, and baking. So that's quite a selection over there. And without further ado, I would like to turn over the mic to Dr. Ranalda Tsosie.
Yeah, I'd like to first acknowledge the Native Voices in STEM, and and just the funders and everybody who is involved, as well as all the attendees. I'd like to give a land acknowledge in the space that I'm in, which is historically inhabited by the Salish, the Kootenai, and the Pend Oreille. There have been other Aboriginal peoples that have used these, Indigenous peoples that have used these spaces as well in the town that I'm presenting from, which is Missoula, Montana. I'd like to just say thank you in giving me the opportunity. She Ranalda Tsosie and Shia Nanisht Ejet Habahanishle Nashasha Bashashin Ashe Dasha Do Ashihi Dashanala Tółikan de Eshe Yaho Do Kut Adene Sanishle. I really wanted to take this opportunity today to talk about really the longstanding water challenges in my home community, as well as what I've done in the past few years to address those water challenges, and how I'm using them to not only help my own community, but other Diné communities in Arizona or across the nation, and especially working with Crow communities as well. So first, I've already said that I'm Diné. I'm from Tółikan, Arizona, which is located here with these clusters of abandoned uranium mines. I'll talk a little bit more about that. I'm a mother of 7 children, 3 of my own birthing and 4 that I raised, and I'm really proud of them. I am officially for getting ready to have 4 out the door, and with 2 of them being college bound. So I'm so excited about that. And just being an empty nester, but I still have a few years for that. I'd like to I acknowledge myself as an environmental chemist, as well as a steward for the environment and Native communities. With respect to my education, I started my educational journey at Diné College. I was a warrior, followed by being a Lobo at the University of New Mexico, where I got a Bachelor's of Science in Chemistry. And then I was a Grizz, but now I'm a Bobcat. So, and that at U of M is where the University of Montana is where I actually got my Ph.D. and I'm currently in my post-doctoral studies at Montana State University. Are my slides moving forward? Oh, there we go. I guess I have to click the space bar. Indigenous communities are really one of the first and probably one of the most impacted communities that are affected by environmental impacts, such as climate change is a big thing right now that we're facing, as well as food and water insecurity. And so in some of these communities really have been advocating for themselves by working with researchers like myself, Indigenous research, as well as non-Indigenous researchers, by incorporating their worldviews and opinions and the direction in which research will go. And I think this is a really great move by Indigenous communities. And also, we also have a number of Indigenous scholars like myself, like Dr. Chief and Dr. DeVore that you're going to get to see in February. And she's got an excellent talk. A lot of these, so many of us that have gone through and are trying to come back and do research within our own communities and help Indigenous communities. And most of us are actually using our own worldviews to address some of the challenges, that environmental challenges that are stemming from in our home communities. It's really been challenging, I have to say, in terms of acceptance by the academy. But I think we're making progress. I mean, we have talks like these, we have different universities that are incorporating programs with Indigenous knowledge and TEK programs and graduate studies. So I think that we're making some good leeway in practice in terms of acceptance in the academy. But what I wanted to talk to you about is Indigenous research is really grounded in 3 ways of knowing. Axiology, which is our Indigenous values, encompasses like respect, relationship, reciprocity, representation, pretty much like a lot of ours. But there are also other values that we have that we incorporate into with respect to axiology. The second is epistemologies, the ways in which we know certain things, the way we teach and the way we learn. And the third is ontology, the way we see our own reality through our own lens. And I think for me, this was really became apparent when I saw Albert Marshall. He's the Mi'kmaq elder who gave a talk about the concept of two-eyed seeing, and that's the ability to navigate with two perspectives or two lenses, and seeing the world from 2 perspectives. And some people might not totally agree with that, but I really believe that when we come to an academic space, we have to do that. We have to see the things that we're trying to accomplish from a Western perspective, but at the same time, we want to hold dear to our heart, close to our heart, the way we grew up, our own worldviews, our beliefs, the way in our own teachings. And for me, this really became Diné science. The major difference between Indigenous knowledge and Western knowledge is really the connectedness to the land and having that sense of place. And Diné science really connected me to research, through education, and allowing me to incorporate all the things that I grew up with, right? I grew up living, practicing traditional Navajo ceremonies, Diné ceremonies, and prayers and songs and stories. It really grounded me in the concepts that have furthered me to not only my research, but the approaches and the frameworks that I use to learn more about the concerns of the environment, the health of the environment, health disparities in my own community. And I think this really helped me in such a way. So Diné science really is an alternative way of viewing the scientific method. It begins with a paradigm in my own culture, as shortened to SMBH. Paradigm really encompasses many aspects of living a life filled with respect, spirituality, tranquility, most importantly, balance and harmony. It represents the 4 life lessons that we undertook as children through stories of Ntsahakes, Nahatah, Ina, and Sihasin. And for me, these lessons and concepts were passed on through oral transmission, through stories and through songs and through ceremonies. But I really want to acknowledge the institution, Diné College. They're the ones that really started using these concepts and in educating their students. And they use these philosophies as their educational framework. And it's really one of the first places that I recall seeing these teachings, and thankful to them for opening my eyes to it and allowing me to see the scientific method from these lens and this perspective. It's not a replacement of the scientific method, but it's an alternative approach in understanding the process of the scientific method. It also, Diné science also implements Indigenous research methodologies, in which is really a fluid and constantly changing approach to understanding how to conduct research in and with Indigenous communities, as well as the practicing the 6 R's that you see here. Of all of these, I think respect is the most important through this entire process, as well as reciprocity, going back through and coming back and collaborating and really collaborating with the community. So the process of Diné science really begins in the East, where Mtsahakes, or the process of thinking, where consciousness and critical thought are conceptualized. It represents creativity, our reasoning, our intellectual development. With respect to the scientific method, if you're thinking and you make an observation, you see something and you start asking yourself questions, that's what this step is. It's that observation and questions, where you begin to ask questions. The next is to the south, where it's not represents and symbolizes planning, leadership, and creativity, gathering of your resources, realizing your own capabilities and possibilities. For the science, with respect to the scientific method, it's like making predictions of the research outcomes, establishing a research plan, and gathering materials and resources so that you know that in the direction that you're going, and that you know what the eventual outcome will be. Then to the west is Ina, which represents life, or it means life or living, but it also can mean implementing. It represents the activation of thought in your plan, setting your plans into action. It embodies production and results. And with respect to the scientific method, this is like testing your hypotheses through experimentation, collecting reproducible data, and analyzing data sets, and revision of like plans or experiments if needed, because you know that within research, there's never just like one way. You always have all these like stops along the way, and you have to rethink your process and reapproach and ask all these additional questions. Then in the north is Sihasin, which is reflection, represents self-awareness, protection, and guidance, wisdom and self-awareness. But really, it's your own ability to for self-evaluation. This is where you're really thinking about the overall drawing and conclusions, maybe even developing, expanding, or rejecting your hypotheses, going back and reflecting on the results. It could mean revising. But this also really includes disseminating the results with the scientific community, but also the community in which that data came from, especially if you're working with an Indigenous community. It's the whole process of Diné science is cyclical. Oftentimes you see the scientific method more of a linear process, but it's actually a cyclic process. It's a continuous process, because you're always revising and adjusting your goals and your plans. Sometimes you have a scientist that will say, oh, what about this? Let's go try this. Well, this didn't work. How can we do? And then the process starts all over and over and over again and reigniting that process of scientific inquiry. So the process of Diné science for me was a framework that I used to really address the research that I was in. And I think it's really one of the most important and vital pieces of the research outcomes that I've learned to really embrace. So in terms of the research that I conducted was really about mining in my home community. I was motivated by all really just asking myself and observing all the many people in my community that were getting sick. People my age were passing, had cancer, had various types of cancer, and people that I went to school with, that they just succumbed to the cancers and are no longer with us. So that really got me wondering, and not to mention that my own family was affected by uranium and cancer as well. So that really motivated me to come back to my home community to find an answer. As you know, when we have a mining company that's coming in, there is so many different things that they want to say, well, this is all the best thing for economic development, it's for jobs, but they never discuss the impacts, the legacies that are left behind, that the health impacts, the environmental impacts. They never discuss that, they never disclose that, and they never show that. And this is just something to this research really identifies those exposures and so forth. And I just wanted the Navajo Nation is really located in the southwest of the US, and it's located here. And this is just the map. This is the location in which where the research took place. The study site, the Teta area, like I said before, is in this area. It's in the Sweetwater community. It started out with uranium mining. There was about 48 to 67 tons of uranium, 67,000 tons of uranium that was mined from the Carrizo Mountains, which is one of the areas. It really left a big legacy within the community. In 2007, there was a report that was published by the US EPA, as well as the Navajo Nation EPA, Abandoned Mine Lands, and the Army Corps of Engineers. And they really did an extensive review of the literature, as well as records, to identify locations of uranium mining activities, as well as abandoned uranium mines. And they really wanted to understand to what extent the damage was. So this is an example of all the the northern AUM site is where Teta is located, and this is a close-up of that, of the different sections. And if you scroll through it, there's a close-up of one little tiny section, which is the Teta area, and you can see the many abandoned uranium mines just in this area. And then different colors, they represent 1/4, 1 mile, and 4 mile buffer zones from the closest abandoned uranium mine. So we're really dealing with a really big problem. There's so many different things, different types of mining that happen. And it began with radium in the early 1900s, and then in 1920s was vanadium, and then uranium. Not to mention the oil development that was happening, as well as coal mining in the western part of the reservation. So there's so much mining and so many benefits to the tribe that were reported, but not necessarily what the impacts are going to be. There are currently many Diné communities that are facing similar challenges with groundwater contamination, the lack of appropriate water resources, as well as infrastructure. Not thankful for COVID, but COVID-19 actually really highlighted the infrastructure and the needs of the Navajo Nation. And there's a lot of projects that are currently happening. But for my project specifically, it really was to obtain community approval of the study, determine the overall characteristics of these unregulated water sources. And I focused on unregulated water sources because those were the sources that nobody really knew much about. People who didn't have access to running water still access these locations, maybe not always for personal drinking water, but definitely for livestock, for agriculture, for ceremony, for like all of these different things. And so to me, I needed to understand what the extent of contamination. And then third was really to analyze the potential of silica polyamine composites as a method of remediation. And we'll talk a little bit more about that. And then eventually optimizing these technologies into a point of use filter, which I am currently doing as part of my postdoc. To better understand the impacts of water, we began by collecting water samples from wells in the Teta area. You can see here is a student that I have gone, and these are other community members. This is my my friend. Her name is Claire. She just passed away yesterday. And she used to come out with me and to do, sample collections. And she was really interested in the work that I was doing. And she's not the only community member that would come out and help, and help with the data collection. But it really meant a lot to me. Sweetwater is the chapter that I was really focused on. But it was bordered, some wells were located in the Tisnas Ponce area, just on the outside, as well as the Mexican water and the Red Mesa chapter. Rhea, can you get me a tissue? And as well as Rock Point, which is down in this end. And so we really focused a lot on collecting water in that area. The research was done the wells were separated into different groups. There was 23 wells that I collected, often consistently on a quarterly basis over the period, a range of 2 years, really 2.5 to 3 years. But I really focused, I would like to say 2 years, where it was really consistent. And I grouped them by location, but as well as the ones that were closest to the Teta area and the furthest and so forth. And the average uranium concentration really was centralized with the mines and the wells that are closest proximity to the Teta area. This area here, which is group 3, it actually was a little further up in elevation, so or down of elevation, and then it was in opposite direction of the flow of groundwater, which is, so here's the Carrizo Mountains, and the groundwater flowed from here down towards the San Juan River. So I think that's the reason why we didn't really see a whole lot of the uranium, the extent of the uranium exceeding uranium concentrations in that area. The wells over here on this side were higher in elevation. They also access, I believe, the same aquifer, but I believe it was further away from the Teta area, so it didn't have as much impact to the uranium mining. The arsenic concentrations were really more widespread. Here you see the arsenic really throughout the entire study site, excluding over here where the elevation was higher and further away from ground on the other side of the groundwater flow. But then we have vanadium concentrations, and here with the vanadium, that one is more located in the northwest part of the study area. But I think this is really something that we're seeing because of groundwater flow. and that most of the vanadium mining really happened way before the uranium. So it's probably slowly traveling towards down gradient with the groundwater. So we're seeing more of that there. I was really surprised. Vanadium was not on my radar at all until I really saw all the data that I focused on. And then I said, okay, vanadium is an issue that we need to deal with. The groups themselves, I just wanted to just give you an update of all the different data for the overall well groups. Most of the wells had, in terms of water quality, had acceptable or good ranges for water quality parameters like pH and turbidity and so forth. In terms of water chemistry, there was really nothing in any of these groups that was really astounding, except for the wells that are in group 2, which had concerning levels of arsenic and vanadium. To me, for us in these wells, they had, they're concerning because they had some of the highest activity for water hauling. And for in groups 3, the iron level concentrations were high. This is a concern not for really for human health as a secondary standard, but it's an additional challenge with respect to the silica polyamine composites and the competition for binding affinity. In group 5, we had wells that were both unregulated, and I also had a regulated source. The regulated water source was actually blended. It started receiving blended water in 2015, so meaning that the water was purchased, they built a pipe from the Farmington area, from the Shiprock area, and they extended it down. And so they started pumping water that was purchased from the city of Farmington and New Mexico and blending it with the groundwater to reduce the levels of arsenic and uranium and so forth. And that the wells that are being sent out, or the water that's being sent out to homes, for the homes that do have access to running water. And so it's just one item that I wanted to note from the wells in this area is that we saw a shift from nitrate, high nitrate, or I get not really high, but a concerning level of nitrate to a concerning level of sulfate. This could be due to a number of different reasons. The oil development in the area, monsoonal effects that we're seeing, lots of different things. So we're still looking into that. The photo below here, this is the Jade Johnson. She was an REU student in our lab in 2018, and she went out and did water sampling. The one thing that I did want to mention is these feral horses. We're seeing a lot of feral horses in the area. And so I need to speed up a little bit. I'm taking my time. And I think this is an additional issue that we need to address, and that is overgrazing and overpopulation, and an additional challenge that these communities have to face. Within the respect to the group 4, we have these 2 wells that seem to always exceed the uranium maximum contaminant limit. Then we have the 3 wells that always exceeded the maximum contaminant limit for arsenic. And then in the same wells, we had high vanadium. And some of these wells, we had vanadium concentrations of up to 256 parts per billion. And the slim wagon was the most concerning because it had almost 89 parts per billion, which is about 3 times the maximum contaminant limit. The one thing that was kind of surprising is the copper is high here, which would be a potential for possibly binding the copper and using it as to regenerating the copper and then selling the copper. I mean, that's just something that our lab has done. Many of these wells are located in close proximity of the abandoned uranium mines in the Teta area. We're also seeing the same thing, the nitrate to sulfate, and many of the water quality parameters are actually acceptable in this area. This one here is just a graph of the levels of the different uranium concentrations. You didn't really see a whole lot in, I don't know why this turned turquoise, but you do see we had really fluctuations. So this was an average. Sometimes we saw as close as 40 parts per billion, and then to like 25 parts per billion. So it really fluctuated in some of the wells. The one thing that was really consistent was the arsenic concentration. And when we compare some of this to the 1999 study of Army Corps of Engineers, there's really only 2 studies that I saw. You can see that in that 9550 and the 9K216, you still had these alarming levels of radon as well as uranium. It seemed to always be in exceedance, and as well as arsenic. You can see that in these ones, they were exceeding the maximum contaminant limit. But at that time, actually, this was after the different MCLs were adjusted. Vanadium is really high at the 592 and the Sweetwater chapter well, which is really concerning, and it remains to be the same today. In 2008, there was another study that was conducted, found that the same 2 wells were exceeding uranium, but surprisingly, the total arsenic in all of the wells that were tested did not show exceeding levels of arsenic, but they also didn't do all the wells in the area. So it just reconfirms the levels, and historical levels are still the same as we're seeing them today. The silica polyamine composites, I'm sure, is the materials that I'm working with. They're metal selective materials. They've been used in remediation, large scale industry and recovery operations. They are made from linear polymers or branch polymers that are surfaces silanized, and then you can add on different ligands that can be selective for like uranium or for arsenic or for copper and so forth. This is just showing the process of the materials in which they're made. The zirconium BPAP actually comes from the BPAP. This is a uranium selective and vanadium selective SPC material. It's doubly substituted. As you can see here, they can be, I can't get this here, which means that there's more binding sites for uranium. When we add a zirconial ion to it, it actually changes the overall charge of the materials, which will make it selective for negatively charged ions such as arsenic and arsenate. In theory, what will happen is that as we're running the feed solution through or the water through, that these metal ions will bind to the surface of the composite. There is some that will break through, but what we're aiming for is that it'll be below the maximum established contaminant limit. This table just shows how BPAP and zirconium BPAP have the materials that I've made, which is this top line as well as the second line, compare to what has been historically made in the lab from other researchers, but also what is commercially available. It actually exceeds commercially available materials or is comparable to that. And this is just showing the selectivity for arsenic. I haven't done the vanadium studies. That's something that I'm working on currently in my research. In terms of BPAC, we've done a synthetic water column elution. It's just saying that despite having multiple ions, we're still binding uranium slowly, but it's still binding, which is promising. The one thing that is the best thing about this material is that it can be regenerated. So within the first two strips, you can remove almost 99% of that uranium that was bound to the surface, and you can regenerate it and reuse it. And they don't lose, these materials don't lose their capacity. After 3,000 test cycles, they lose about 10% of their capacity. So they're the possibility of regenerating is really high. We are experiencing issues with the arsenic selectivity. We can bind, but the problem is that it's hard to remove that. I know I'm almost running out of filter time. This is the filter that the prototype that we made. It's experiencing flow issues right now. But the one thing that's promising is that in using equilibrium studies, we can remove 95 to 99% of uranium and arsenic, and that in well water, it's still selective in those types of materials. So we just need to get a hold of this flow issues. With respect to concluding thoughts, there is a place for Indigenous knowledge and science and scientific research. My main motivation was the quality of life for my community as well as my people. Implementing these SMBH philosophies is accomplishable. We can do it. And that working with Indigenous research methodologies when working with and in Indigenous communities is important. Most importantly, we went back and did a final report for the chapter as well as the surrounding communities, just really talking about the scope of the research, the summary of the results, and recommendations for that community. In addition to this, I'm working on that optimization of the filter at MSU for and tackling those flow issues. I'm also doing these implementation studies that I hope I will be getting to next year. And then I also have a web application called Tółikan, which uses GPS or cell phone technology to really bring forth the water quality parameters of the certain wells in the community, which I hope will come to light in the next few years. In terms of the postdoc, we're really trying to optimize these filters so that they're compact, they're versatile, they're customizable to the community that they're in. And we're hoping to develop cartridges. The one thing is we need to make it affordable to the community. A part of the postdoctoral research is working and collaborating with different MSU departments, such as the Makerspace and Engineering Machine Lab, as well as working with the Department of Civil and Environmental Engineering with the mechanical engineering students on their senior capstone projects, as well as collaborating with the Montana EPSCoR on a cruise and commercialization innovation internship of a student that's going to be working with me. Her name is Isabel Melmer. And then collaborations, of course, continued collaborations with Diné and Crow communities. This is an example of what the data that you should be able to see when you are using that Tółikan app, a water quality application, web application, but it's still in the process of being developed. I'd like to acknowledge the following funding sources. My family, of course, they've always been there. Most importantly, the communities of Sweetwater, Emmanuel, Mission, Red Mesa, and Tisnospas, and all the different scholarships and fellowship programs that has helped me along the way. And with that, ahiaha and thank you. And below is my contact information.
All right. Thank you very much, Dr. Tsosie. That was a very good and insightful presentation with certainly a lot of info, both on the contextual and scientific sides. Again, like pass on my condolences. And then again, I'd like to thank you and everybody who joined us today. I see there's a lot of people from both the CHI departments and the Indigifuse trainees, as well as other NVIS attendees. And of course, all the sources of funding for this program, which makes it all possible to have you invited over here with Indigifuse, Sloan, the Chemie department, and WRRC. And of course, I'd like to make a small invite to our next seminar, which is going to be on Valentine's Day, February 14th, where Dr. Sherry DeVore is going to be coming here in person and on Zoom to talk about mining and wildfire-driven changes which alter metal mobilization, and offering some of those mechanistic insights. So without further ado, I would like to open up the Q&A for maybe 1 to 2 questions. I think there is a question in the chat, so I think we could open with that one if nobody has any objection to that. So the first one, there is one in the chat that happened during the presentation from Shanna. And they wanted to ask, can you clarify the difference between water quality and water chemistry on one of your slides? I believe that one was the one which was a bit more qualitative, which just listed the water quality as being like adequate or like better or stuff like that.
So water, thank you for the question, Shanna. So water quality is measuring things like conductivity, pH, turbidity, total dissolved solids, and yeah, I think that's the 3. Temperature, water chemistry is actually more in depth. You're looking at ions specifically that are found in the water. So that's where you get the uranium concentrations, the arsenic concentrations. You can also get anions. So like you can get both cation concentrations as well as anion concentrations. So like nitrate, sulfate, and phosphate. There's like so many different negatively charged ions that can be analyzed. So that's the major difference between water quality and water chemistry.
All right. Thank you very much for the answer, Dr. Tsosie. And we do have a spot for, I believe, 1 more question, right, Dr. Chief? All right. Oh, yeah. So we're good for 1 more question if somebody wants to jump in.
I have a question.
All right. Lyra?
Okay, sorry about that. Is it good now? It's on.
No, it's not. You can put it in the chat and I can read it out loud, Lyra, if you wanted to.
Okay, how about now?
Okay, that's good.
Okay, that's better. Sorry, it's echoing from another seminar. Great presentation. I'm sorry about the loss of your friend. I know that her work went to a great cause and you just gotta keep working in that direction for her. We're all cheering for you. My question was about the slide with the acceptable levels of arsenic and uranium. I noticed that in the group 5, in my head, the groundwater is going the same way in that group. So why is it that in some columns only arsenic is found and then no uranium, but then the opposite is true where you only find uranium, then there's no arsenic, but there's not both present, even if it's in the same water in the same group. So why wouldn't there be both? Why one or the other?
So there could be a number of different reasons. So one, it could be so not all the wells are at the same, drilled to the same depth. So some of them are shallower wells and some are really deep wells. That could be an issue. It also could be the geology in the area that's contributing to that area. So for an example, oftentimes that's one thing that I do have asked myself that many times, why we should be able to see like levels of arsenic and vanadium and uranium and all of these, and the geology in that area is very complicated. So it's hard to say, to pinpoint unless you do an extensive research, but that's definitely a great research question for another graduate student that's looking to investigate that. That's a great question. But
Okay,
I
thanks.
don't have an answer for you. That's always something that's really baffled me. I've talked with my advisor and many of my other advisors and different individuals and professionals that work in that same area. And that's just something that we've always found in historical documents, as well as other dissertations and theses. They've always seen the different levels and the different concentrations. And I think the major contributor to that question is really the geology is slightly different in that area, and that they access maybe different aquifers or different parts of the aquifer.
That's very interesting. Yeah, I'm curious to see if there's some sort of competing chemistry going on, but that's cool that you guys are looking into that. Thank you.
Mhm. And I just wanted to say thank you to Anne for sharing that posting at New Mexico Tech. I will definitely look into it because I really want to get closer to home. I've been away far too long.
Thank you so much again, Dr. Tsosie. I'm going to jump in here and thank you, Anton, for doing the introductions and for thanking all of our co-sponsors. And thank you, Dr. Steve and Indigenous for creating Native Voices in STEM and partnering with different departments and partners across campus. We have started inviting our speakers to stay on for an additional 30 minutes for a student-focused Q&A. So at this time, we would say thank you to everybody who has joined us. The seminar is now officially over, but to the students in chemical and environmental engineering and the Sloan scholars and Indigenous scholars, if you have some questions for Dr. Tsosie related to her research or her career trajectory, we invite you to stay. We'll take a 5-minute bio break and then turn off the recording, and then we'll move on to some student-focused Q&A. So thank you, everyone.
Thank you.
Thank you very much.